So how do you balance redox reactions? Most redox reactions, a lot of redox reactions are not straightforward as far as balancing is concerned because they might involve a lot of reactants and products. If you have a simple redox reaction, you can probably just balance by trial and error. But if you have a reaction like this, okay, chances are you're going to have a hard time balancing it by just trial and error. Now, it helps a little bit if you do a little algebra to balance it, but it's almost a necessity. It's pretty much a necessity that you take into account electrons lost and electrons gained when balancing a redox reaction. That helps a lot in figuring it out, especially if you're going to do it by trial and error. Okay, so in a balanced redox reaction, you have to realize that if something gets oxidized, something else must get reduced. Okay? If something loses electrons, those electrons go somewhere else. So if something loses electrons, those electrons are gained by something else. So if something is oxidized, something else gets reduced. What did we say got reduced here? Your nitrogen went from a +5 to what? A +2, right? So that's how much? A change of 3, that means gain or loss of electrons. This is reduction, right? Reduction, do you gain electrons or lose electrons? Gain electrons. Gain of how many electrons? 3 electrons per nitrogen, right? And what happened to your copper? Remember what did happen to our copper? From 0 to +2, right? That's oxidation. So when you become more positive, that means you've lost electrons. How many electrons here lost? 2 electrons for every copper. All right, so since electrons lost must be equal to electrons gained, what that tells us is every time we get one of these, we're gaining 3 electrons. We have to be losing 2 electrons somewhere, 3 electrons somewhere also, but this one only gives you 2 electrons. What should we do to balance electrons lost and gain? We adjust coefficients, right? So we find the least common multiple of 3 and 2. What's the least common multiple of 3 and 2? 6. How can I make 3 equal what do I multiply 3 with to get 6? 2. So what I need to do is this has to happen, okay? This thing has to happen 2 times, and every time this thing happens, reduction happens twice, my oxidation must happen 3 times in order to balance electrons lost and gained. So what that means is if my coefficient for this is 2, then my coefficient for this other one must be 3. So that ratio must be maintained 2:3. So if I were to end up balancing this equation with a 4 over here, what would my coefficient over here be? It would have to be a 6. 4:6 is the same thing as 2:3. If I went back and forth, tried to balance this equation, I ended up with an 8 over here, what would this have to be? This would have to be a 12. Okay? 2:3, 4:6, 8:12. Okay? So that sort of fixes that. That constraint fixes those two and simplifies things for you. You have less to worry about in terms of trying to adjust coefficients. Okay? Now, as far as balancing the rest of this equation, you should already know how to do that. So I'm just going to leave it at that. Okay? Try to balance this on your own. Okay? But the important thing to realize is these other coefficients you can change, okay? But this too must be on a 2:3 ratio. Or do you need me to go through this process just for illustration? Or can you do it on your own? Okay. Uh, All right, so that has to be a 2:3. One thing I like to do instead of going back and forth using trial and error is I use algebra. So I just assign a letter here. I'm gonna call this A, B, 2, 3. I'm just gonna fix that at 2 and 3. Okay, and then so the other coefficient is C. Okay, so I can balance my equation like this. So I'm gonna represent my unknown coefficients by letters. So what do I know? If I were to balance copper, how many coppers do I have on the left? A times 1, right? How many coppers do I have on the right? 3. This is the only place I find copper. 3 times 1. If I were to balance H, what would I have on the left? How many H's do I have on the left? B times 1. How many H's do I have on the right? 2C, right? How about nitrogen? How do I balance nitrogen? How many nitrogens do I have on the left? B, right? How many nitrogens do I have on the right? There's 2 times 1 there, plus how many nitrogens here? 3 times 2, that's 6, right? And finally, if I want to balance oxygen, what should I have? B times 3, so that's 3B. How many oxygens do I have on the right? There's oxygens here, so that's 2, plus oxygens here is how many? 2 times 3, that's 6, times 3, what's 6 times 3? 18, plus another oxygen here, C, right? Do I know what A is? A is 3. Okay. What else do I know? Do I know what B is? It's 8. Do I know what C is? I know what B is, so C is B over 2, right? So what's B over 2? 4. Correct? Alright, so let's try that. Let's verify. I have 3 coppers plus 8 HNO3 gives me 2NO plus 3 CuNO3 2 plus 4 H2O. Let's see if it's balanced. How many coppers do you have on the left? 3. 3 on the right. Hydrogens? 8. 4 times 2, 8 on the right. Nitrogens? 8 on the left. Okay, how many do I have on the right? 2 here, and then 3 times 2, 6 there. That's 8. Okay. Oxygens, how many on the left? 8 times 3 is 24. On the right, I have 2 plus 18 plus 4. That's 24. So this equation is balanced. Okay. See how easy